Hey look, more binary. This time we're doing subtraction. 9.4.2, the interrelationship between hardware and software for the software design and development syllabus. Now, what we're going to do is look at the way a CPU does subtraction, nothing else. And before we go any further, yeah, there are easier ways of doing this, but this is not how a CPU does the job. What we're doing is looking at the way a CPU works. So, as we've mentioned, CPUs can't do anything but add and shift. So how does a CPU subtract? Previous video talking about adding negatives and adding a 2's complement negative. So before we learned about creating a 2's complement creating negative numbers via shift and sign and modulus, but also 2's complement. This one's a 2C. So the steps in a subtraction. Number one rule, make sure both numbers are the same length. If your subtractor, the number you are subtracting that is smaller or has less bits in it than the number you are subtracting, add leading zeros to make them the same length. Find the 2's complement of the number to subtract. For example, if the sum we're doing is 5 minus 3, we're going to find the 2's complement of 3, so the calculation is 5 plus minus 3. We'll add the 2's complement. Now, if the sum has a positive result, so 5 minus 3 equals 2, that is a positive number result, then discard the leading one, and there is your answer. If the sum has a negative result, if we did this instead of 5 minus 3, we did 3 minus 5, which gives minus 2. That's a negative result. The answer is a 2's complement. Therefore, to figure out what the number is, you need to take the 1's complement of the 2's complement and invert the numbers. In other words, the result will be a 2's complement. Okay, let's move on. Here we go. 6 minus 3 equals 3. Nice, easy one to start. 6 is 1, 1, 0. 3 is 0, 1, 1. We need to find the 1's complement, then 2's complement of the 3. So we invert the 0, 1, 1, which gives 1, 0, 0. The 2's complement, add 1 to the 1's complement. So now my sum is 1, 1, 0 plus 1, 0, 1 gives 1, 0, 1, 1. Drop the leading 1, 0, 1, 1. The answer is 3. We know that calculation is correct because 3 in binary is 0, 1, 1. My answer is 1, 0, 1, 1. When I drop the leading 1, 0, 1, 1. 3. Okay, so there's a simple version of that. Let's now try the other way around. 3 minus 6. So we know the answer is minus 3. So 3, 0, 1, 6, 1, 1, 0. Working on the 6. The 1's complement is the invert of 1, 1, 0. 0, 0, 1. 2's complement, add 1. 0, 1, 0. So the calculation now is 0, 1, 1 plus 0, 1, 0 equals 1, 0, 1. Now that is a 2's complement number. How do we get the 1's complement? Well, it's a negative number. So we get the 1's complement by subtracting 1, 1, 0, 0, inverting the number 0, 1, 1 equals 3. Okay, so we've now worked out what happens in a subtraction if the number is, the product is positive, or the result, sorry, is positive. And now we also know what happens if the result of the number is negative. It's a 2's complement, which you then have to turn back into an integer. Here is a more difficult example, 117 minus 92. So here we have the number line, just to make sure we know what we're doing. 117 minus 92 is 25. So here's my number line. 117 is 1, 1, 1, 0, 1, 0, 1. 92 is 1, 0, 1, 1, 1, 0, 0. And the answer we're looking for, 25, is 1, 1, 0, 0, 1. So this is the numbers we're looking for when we do our calculation. And we're looking for an answer of 1, 1, 0, 0, 1. So when we go and do the calculation, 92 is the subtractor. So 92, the 1's complement is 1, 0, 0, 0, 1, 1. The 2's complement is that plus 1, 1, 0, 0, 1, 0, 0. And now the calculation is 117 plus minus 92 equals 1, 0, 0, 1, 1, 0, 0, 1 When I drop the leading 1, there's my answer, 11001, which we know from the previous slide is 25. Doing it the other way around, 92 minus 117 equals minus 25. So once again, 92 is 1011100. 117, 1110101. The 1's complement 117. Invert the numbers, 000, 1010. The 2's complement, add 1 to that 1's complement, is 000, 1011. So when we do this calculation, we know the answer is going to be negative. Here's the calculation. 92 minus 117 gives me an answer in 2's complement of 1100111. Turn that into a 1's complement. Subtract the 1, which is now 1100110. My integer value, my number, is therefore 11001, which is minus 25, which is 25, which means 92 minus 117 equals minus 25. Now there's no examples to go with this because the next slide is going to start looking at division where we'll actually start to use this process. But here we go, summing it all up. We don't subtract, we add negatives. To get a negative number, you find its 2's complement. To get a 1's complement, invert 1's and 0's. To get a 2's complement, add 1 to the 1's complement. Answers that are positive, drop the leading 1, there's an integer value. Answers that are negative are 2's complements, convert it back to an integer. And we do this specifically in software design so that we can do the next step, which is binary division, which will be the subject of the next video. Thank you very much for watching.